In this video, we're going to look at resultant vectors, but when we have our vectors in column vector notation. Now remember, a column vector is something like our vector A is equal to something like 2, 5, where the top number is the x direction, so that means 2 to the right, and our bottom number is in the y direction, so that means 5 up. If we had another vector b, which is 1 minus 3, then that one is 1 right, and the bottom one would be 3 down. Remember, negatives are in the opposite direction. So let's consider how we could find the resultant A plus B. We're going to be looking for how to do this as a column vector, but let's draw it out first. So first of all, we need to draw A, which is 2, 5. So if we start down here, we've got to go 2 across and then 5 up. So that's going to take us up to there. So our column vector goes like that, up there. So that's A. And then B is starting from the end of A. We then go 1 across and 3 down. So we're going to get to there. So B is like that. And A plus B is going from the very beginning to the very end. That gives us A plus B there. Now the column vector for A plus B, we notice that we go 1, 2, 3 across and 2 up, which means the column vector is 3, 2. Now something you should notice here is if we were to write this out as a column vector sum, we would have 2, 5 plus 1 minus 3 equals 3, 2. And what you should notice is that 2 plus 1 equals 3, and 5 plus minus 3 equals 2. So when we have our vector in column vector notation, we can just add up the components to find the resultant vector. If we were to subtract these vectors, we would do a very similar thing. So let's have a look at that. If we were to do A minus B, we would do A first. So again, we would go 2 across and 5 up. So from there this time, we'd go up to there. 2 across and 5 up, so that would be A. B would then go from the end of that, but we're doing minus B. And minus B, if we look at what B was again, B was 1 minus 3. So minus B equals minus 1, 3. So B will be minus 1 across and 3 up. It's going to intersect slightly with our last drawing. 1 across and 3 up will take us to there. That's B. So our resultant goes from the very beginning, there, up to there. That would be A minus B there. Once again, if we were to write it out in component vector form, we get 2, 5 minus 1 minus 3 equals, and we see that from the very beginning to the end we go 1 across, so we get 1, and we go 8 up, so we get 8. And once again, 2 minus 1 gives us 1, and 5 minus 3, so 5 plus 3 gives us the 8. So let's have a look at another example. This time we have got P, our vector P, is equal to 3 minus 2, and our vector Q is equal to 1, 4. We can work out from here P plus Q. So P plus Q in component vector form would just be 3 minus 2 plus 1, 4. 3 plus 1 gives us 4 on the top, minus 2 plus 4 gives us 2 on the bottom. So P plus Q would be 4, 2. We could do P minus Q. This would be 3 minus 2 minus 1, 4. This time we would get 3 minus 1 is 2, minus 2 minus 4 is minus 6. And we could also do Q minus P. In this case we would get 1, 4 minus 3 minus 2, which is equal to 1 minus 3 is minus 2, and 4 minus minus 2 is 4 plus 2 is 6. You should notice as well that P minus Q and Q minus P are negatives of each other. So they are the same magnitude but in opposite directions. We could also draw these out, and sometimes you will be asked to draw the vectors, but most of the time if we're dealing with component form on column vectors, we can just perform calculations like this. So to recap all the rules that we have here, if we have things in column vectors, then if P is equal to the column vector A, B, and Q is equal to the column vector C, D, then we have two things. We have P plus Q is equal to the column vector A plus C and B plus D, so adding the two top numbers, adding the two bottom numbers within the vector, and P minus Q is equal to A minus C, B minus D in the same way. And that is all we have to do to add and subtract vectors that are given as column vectors.